Alright, I was pretty happy that I got the drop targets working, but as you can see there's another problem. That E is on all the time. Okay, so I have that E drop target light that's on all the time, and on the schematics I've got for the playfield schematics, here's where the Sharpshooter LEDs are, or light bulbs are. And there's the E, and if you follow that wire back, it's a gray-green wire coming to pin 5, and it says to J6 on LDU2. The LDU is the lamp driver unit. So I'm going to look and follow pin 5 of J6 on LDU2 back to see where it goes. Let's see here. J6 is right here, and it's interesting how they used to write the schematics. Here's pin 5 here, and I'm going to follow that back, and it connects to Q39. And the symbol is kind of like a diode with 2 feeds into it, and that's a thyristor. And one's the middle lead is a gate which controls current. So on a thyristor, once the gate allows current, it turns that device on, it stays on, it latches on, and then it'll stay on until you remove power from the cathode to anode connection. So I'm going to pull up the board and take a look at it. Okay, so I'm just using a digital multimeter set to resistance, and I'm going to pick on Q40. I'm going to pick on Q40, which is right next to 39, which is the one I think I have in question. I'm going to put the common lead on the cathode and the positive lead on the anode, and it's open. And then I'm going to move the positive to the gate, and there's 17 meg ohms of resistance from the cathode to the gate. Now I'm going to look at Q39, and same thing, cathode to anode, it's open. But when I go cathode to gate, cathode to gate, it's open. And that should have some level of resistance. It should not be open. So I'm just going to go to the next one just to make sure. And I'm going to go cathode to gate, and it's 12 meg. So we got a bad thyristor here, Q39. So I will order one, and be my first shot at soldering. We'll see how we do. So first step for replacing these thyristors is to cut out the old ones. So 39 is bad. I'm just going to cut off, I'm going to leave the legs on here so that I can remove the solder. You just cut off the head of the thyristor, and then what that leaves on the board is, you can see the legs sticking out there. And I'll use that, I'll pull on them as I desolder them. Okay, first step is to remove the legs that I cut off, so that's pretty straightforward. Just take needle nose pliers, grab the wire, heat up the solder, and remove the wire. I'm going to do that for all 3 thyristors, and then I'm going to come back through with the solder sucker and remove the excess solder. So this is a solder removal tool, solder sucker, some call it. You just pump it and then push that, and it sucks the solder away. So what I'm going to do is heat up these holes, get the solder nice and warm, and then I'm going to suck it up. So I'll do one on camera and then finish the rest off camera. So just heat up the solder and remove it. I think I missed that one, so I'm going to do it again. Anyway, that's the technique. I'm going to do all these holes. So right now I've got a thyristor installed without it being soldered yet. It's right here in this thyristor location. I'm going to try to solder this with the camera running, but I don't know if I can do it because it's two-handed. I got to get in there close, but I'm going to try. You just heat the combination of the trace and the leg get them hot, and then apply solder when it's hot. Okay, so I just did one leg, and I don't know how the focus of the camera will work, but you can see a nice round solder island there, and then I'll do the other two.